Question 3 is a longer answer question about the group 1 elements. It gives you some information about the group 1 elements in this table here. It gives you the total number of electrons in each atom of lithium, sodium and potassium. It gives you the radius of the atom. It also tells you the energy needed to remove one electron from its outer shell. So just pause the video here and take a little bit of time to look over this information again. The question asks, what trends does the table show and how does the number of electron shells link to these trends? Okay, let's look at the trends to start with then. The first trend we can see is that as the number of electrons in each atom increases, going from lithium to sodium to potassium, so does the radius of the atom, 152 to 186 to 231. We've got the reverse trend happening then with the energy needed to remove the electron from the outer shell. We've got the largest number for lithium, then for sodium, and then for potassium. So that's the first thing you should do in this question, is to point out those trends. That's what's asked for to start with. Then we need to explain this using ideas about electron shells. So let's have a look at the 3 atoms. So here's the atomic structure for the 3 atoms that are shown in the table. The first thing to note is that the more electrons in the atom, the more shells are needed to hold them. In lithium you've got 3 electrons, so you've got 2 shells. The first shell's got 2 electrons, the next shell's got 1 electron. Then sodium has got 11 electrons, so 2 in the first shell, 8, and then the 1 in the outer shell. Potassium has got 19 electrons, so 2 in the first shell, then 8 in the second, 8 in the third shell, and then the final shell again contains 1. So due to there being more electrons, there needs to be more electron shells. Now the more electron shells there are, obviously the larger the atomic radius. Also, the larger the atomic radius, the further the outer electron is from the nucleus. You can see that very clearly. The distance between this outer electron here and the nucleus is bigger for potassium than it is for lithium. As well as that, there are more inner shells that shield the outer electron from the nucleus. So here you've got 2 inner shells that shield the electrons from the nucleus. On potassium there's 3 electron shells that are shielding the nucleus from the electron. Now both of these points together result in a weaker force of attraction between the electrons and the protons in the nucleus. Remember, electrons are negative, protons in the nucleus are positive, so the two of them are going to attract together. The greater this distance is, the weaker the force of that attraction, and also the more electrons there are shielding the two, again, the weaker the force of attraction between them. And then because of that, less energy is needed to remove this outer electron, and those are the trends that you're asked for in the mark scheme. Pause this video here, just check through these points, make sure you're happy with them. Okay, now have a look at the marks. Pause the video here and check over the points on the mark scheme. Notice that for a level 3 answer, so that's your 5 or 6 marks, you need to identify both of the trends and how they link to the electron shells. If you've done everything that we did on the PowerPoint, then you've covered all marks for a 6 mark answer.